Application of arithmetic sequences. We often get shape questions or toothpick type shape questions with number patterns. Sometimes it's counting toothpicks or blocks in this case. In this question, it's actually not looking at the number of blocks, but the relationship between the snake number that we're up to, which is of course our n, and the perimeter of the snake shape. So if you're asked to deal with this, obviously the first thing you want to do is just sort of work out the perimeter of one shape. So perimeter 1 is 10. Now you could just work out the perimeter of this one by counting, but you could also identify what's being added in each situation. So this is a new tile, this is a new tile, and this is a new tile. And to that perimeter has been added 1, 2, 3, 4, 5, 6 units. So my perimeter here, perimeter 2, is 16. And from this snake here, 1's been added, 1 was added here. So yep, we're adding 6 every time. So our common difference is 6 and our starting term is 10. You could count the perimeter of them all just to double check that you're right, but I'm right. Now they're saying let Pn be the perimeter of the snake shape n. That's just saying that we want P instead of T for term 1, it's going to be P, perimeter 1. Write a recurrence relationship for the situation. Now, depending on the question, it will depend whether you use a recurrence relationship or, as we'll do later, a Tn rule. Since it asks for the recurrence relationship, then we'll have to start with our recurrence relationship form. T1 is A, Tn plus 1 is Tn plus D. So this is the general form of the recurrence relationship, where it's how do we get to the next term from the term before it. Identify A, our first term, 10, and D, our common difference, plus 6. Then just substitute in your values. So my recurrence relationship for this, T1 is 10, Tn plus 1 is Tn plus 6. We have a recurrence relationship for the situation. It's a really good idea to show this working, to write the general form and write what you know and then write your answer. This is appropriate working. Use the recurrence relation to generate the next value and create a table of values. So your table of values would definitely start with 1, because you can't have, we don't have 0 snakes in this scenario. With patterns, you will usually start with n equals 1. When we get to finance, we'll start with n equals 0. But for the general patterns, start with n is 1, the first term in the pattern. Makes sense. We don't have 0 terms in a pattern. We start with the first term. 3, 4. Now your options for a table of values are, of course, enter your first value, which is 10, hit enter, so it's saved over here, and then I want to add 6 each time. So I've got 4 terms there, which I can copy into my table. That's usually the quickest way of doing it, rather than getting a table of values and getting it into y equals. To graph the relationship, we're just graphing y over x. Probably better off using graph paper, of course, for this. Oops. So of course Measuring your gradations, you'll only need 1, 2, 3, 4 on the bottom. This is number of snakes. Or just n. That would be fine too. We need to go up to 28. What would happen if I went 4, 8, 12, 16, 20, 24? Let's sneak up there and manage 28 and we're good. And so this is Pn. And graph your points. 1 to 10, 2 to 16, 3 to 22, 4 to 28, and note that an arithmetic relationship, sorry that went wonky, is always going to be in a straight line. Don't draw them, so don't draw a line, because there's no intermediate values. You wouldn't get position 1.5 or position 2.5. So don't join this with a line, you are just graphing the points. And then they've asked us to write the rule for the nth term in this sequence and use it to find the perimeter of the 50th snake. So the question has said the nth term, and finding the 50th snake, like you really don't want to do that recursively with your, oh, I lost count. You know, it's just a bad idea. So if you've got to find a term that's quite a large value of n, or if they say the rule for the nth term, then you know you're going to use the Tn rule. Tn is a plus n minus 1 times d. Really good idea to write out Tn, n, a, and d. Now we have to write the rule for the nth term. So that will mean for the first one, I don't know these. They stay in the rule because it's still just the nth term. So you keep your n. A was 10, D was 6. So Tn equals 10 plus n minus 1 times 6. That is your nth rule. Then let n equal 50 for the 50th snake. T50 is 10 plus 50 minus 1 is 49 times 6. .304 is the perimeter of the 50th snake, and because it was a word question, word answer, the perimeter of this 50th snake is 304 units. There we go. So that's a bit of a look at using arithmetic sequences with shape patterns.